Hello. In this short kind of tutorial, I will try to show how to build a multi-body part where the different parts depend on each other in the geometry and location of features such as holes, location holes, etc. So physically, those features that are depend on each other are bound in the file very safely and in a very stable way. Yet these are three different parts where we can export a different drawing for each one of the parts for manufacturing. So the feature that we are consisting on is the thing that was SolidWorks introduced like 10 or 15 years ago, multi-body parts. So you can see in the tree manager tree, we have three bodies. So I'm going to drag the tree and see the basic. So in this particular one, since this is a tin product, I'm starting with a sketch which is just a line, and since it is a tin, I just need to identify the thickness of the tin and the direction. So the contour, the important contour is the outer one, and the thickness of the material go inward. Okay, make sure that it's in the right direction. Thickness of material typically is 5 millimeters. So we have the first part. This is the base part, which is the half of this product, which is a double side rim with a core. Then we design the core. Now, what I know about the core, there will be some kind of let's cut it in, make a cross section so we can see. What is important for me when designing the core is that this face here, I know that the thickness of the core is going to be 8 millimeters, and I know that this face needs to be ½ inch from the center of the part. So no matter what changes I will make, as long as this dimension is kept, then I will be okay. If, for example, I decide to change the thickness of the material, now it will be 6 millimeters or 10 millimeters, doesn't really matter. It will be kept. This the feature which is important to me. Again, I'm doing it in thin metal, and here, let's go to the feature itself. I'm going to the edit feature. I need to mark, uncheck the merge results. So I will not have one body, I will have multi-bodies. So now I have two separate bodies. I can later export those bodies into separate files, but they're connected to each other. Okay. This is just a sketch that I made, the holes, the necessary holes to fix the two parts together and to fix the core into the machine. So this feature can be applied for as many bodies as I choose. In this case, this feature, this cut extrude, apply to both bodies. And here we have the chamfer. Chamfer cannot be applied to both bodies. Chamfer has to be separate. We cannot use the same chamfer for two different bodies. Now I made this command, which is mirror body, not mirror feature, mirror body. So I have two separate bodies already. You can see in the file manager tree. You can rename each of the body. Automatically, it will take the name. Each body will take the name of the last command that was done to create this body. For example, this body, this what I called here rim L, naturally would be mirror 1 here. So I rename it so I can identify this is the core, the original rim, and rim L for me it's a sign that I know it's a copy of something. Now I add this feature of the core here. Now you see that when I did that boss. You need to make sure that feature scope, it is merge result. You see that it is checked. The merge result is checked, which means that whatever feature that would be, it will be create a joint body, but I can indicate on which body it should be integrated with. And so it could not all bodies, but I selected bodies, and then manually I clicked the intended body. And now, and as you can see, this circular is a feature, not circular bodies, but features. So it will have to be connected to this last body. This is a cut. Okay. So now now we have the body. We have the whole part. If for some reason I decide, for example, to change the location of these holes, it will apply to all bodies. This is the sketch that is responsible for the whole location, and I only need to change that. I know that if I build everything correctly, this change will apply to all bodies. We are avoiding the risk, for example, that I will create one half with one set of location, which later on, because of some mistake, will not fit the holes on the other part. Since it's the same sketch that is making the holes and it's the same part, it's not two parts that are connected via some third assembly, for example, then I'm avoiding the risk of having such thing that eventually I will have two parts that cannot integrate properly. But now I want to have this thing separate. So first of all, let's see the advantage of working like this. And first of all, look at the top of the Tree Manager T, there is the configuration button. So here I can right-click the first configuration and choose add the rivet configuration or add a new explode view. So I already created this explode view. So this is double click and I can see it separately. Double click again. But here you see I have two parts. It's three parts, but technically those three parts are actually, these two parts are identical. So that would be one part, which is the rim and the core. This is the second part. So I don't need to, I could, but I don't need to create three configurations. I only need this, which is the core. If I double click it, then that whole part is just the core. And if I will double click the half rim, that will be the part. And if I double click the assembly, I will get the whole thing in order for myself to understand what I did, make sure that everything is sitting properly, and it is looking just as it should. And now I just noticed that I'm missing Schaefer here. So I will go and edit. So in order for that, okay, pay attention in the product manager tree. You see I have the last two commands are body delete. I will explain how they are working later, but since these are the last two commands that I create in order to divert the configurations, I am dragging this bar above this, and I will go to the command of no, I will create a different sorry, a different feature. Let's go to Schaefer. Let's make it 1 millimeter, 45 degrees. I might as well do it on one of them and make a pattern, but there are only 6. So I try to avoid patterns. Okay. Now I want to create drawings of this thing. Okay, first of all, I'm going to explain how I'm making those 3 configuration. So basically, let's for the example, I will create an unnecessary configuration of rim left. Okay, so I'm going back here. I'm standing on the going to for the configuration. I'm pressing the configuration, right-clicking this, and I will choose add derived configuration. Okay, and on this, okay, derived configuration is a configuration that uses the father configuration. Everything that exists there will exist also in the derived configuration, and whatever I will add while in the configuration will be applicable only for that specific configuration. So add derived configuration. I will give it a name, rim L, rim left. And now I would go to the bodies. I will use the control to choose rim and core. So I'm leaving unselected only rim left. Then I stand on one of them, right click, and choose delete. And now this is all remains. So this is the part now. If I now go to the new and select make drawing from part, I will select the template I want. Okay. And now I have I can drag here the part. Whoops. The whole SolidWorks crashed. Okay, let's try that again. Just before I move on, this is something I do. I know that this command was isolating the rim left. So I'm renaming it just for me to know. So rim L isolate. And let's do the same to the core. Core, isolate. And this will be rim isolate. Okay, let's go back to the rim L for the example. Sorry. Okay, mistakenly I put it here. Never mind. Let's go for this one. I'm going to delete it anyway. It's just for the example. So now we have this part, and let's go again. Make drawing from part. Okay, let's save it this time before we continue. Okay, make drawing from part. Choose the right template. Sorry for the noise. Okay, here it is. I can change the scale, of course. Let's go for 1 to 5. Like a cross section. Okay, now I can give all the dimension, etc. Now, what's nice about it, first of all, personally, I rather have one drawing with few sheets that describe the whole parts. So I can go to new sheet now, add a sheet. And going for the drawing. And let's, just for the example, I'm dragging this here again. Now, obviously, I don't need it because I already have it in sheet number 1. But now I can stand on it, right click, go for properties, and choose the core, for example. And now this is the core. Okay, so all what's nice about it is if I go for find reference, here is the drawing, one drawing that will have all the sheets that describe the part, and there's one file. So as long as you have this drawing and this file, you cover everything. You have one file that includes all the data. You have one drawing that includes all the data. So we are limiting the risk of, if you attempt to open a drawing and without the presence of the part itself, it will not open. So this is my method. Of course, now later on, just to conclude, let me just delete this because I don't need it. Go back here. Delete. No, it will not allow me to delete because the drawing is open. Let's close this drawing without saving. Don't save. Okay, sorry about it. So once I close the drawing, which was depending on this configuration, I could delete it. And now I can delete this command either. Okay, now I want to export an XT. So two ways. Either I can go to each of the configuration and save as parasolid xt, or the other option, if I don't want to do that, I can stay here, go to the file manager tree, to the bodies, and right click the rim and choose insert into new part. And here we can either go for a parasolid or for a part with no history. Let's see how it works. So I need to navigate to the right location. Let's just put it on the desktop now. And now we will call it just the rim, okay? Save. And now look, this is the part. We have all the feature. It's not a parasolid. It is a real part, but there is nothing in the file manager tree. This is kind of a bug. If I attempt to open a sketch here, if I will open a sketch and then close it, okay, it was just kind of a manipulation. This. Oh, just a second. Okay, forget about it. So you see now there is this strange icon, which means that this is the part I can continue to work on that. I can create something, doesn't really matter what. It's a second. Okay, I can open a sketch here. I can do whatever I like. Doesn't really matter. So all the commands that I'm doing will appear here, but everything that happens prior to that will be blocked. If I want access to this, then just deleting this, I'm right-clicking this, edit in context, and that will bring back the original part. So I can do the changes prior to that. That apply also if I want to make an assembly using, if I really want to make assembly with these parts, I just need, I can either, the way I prefer to do it, for example, let's take a, have a look, how do I make an assembly from this part? So I'm going here, make assembly from part. And I have something here, okay? This is the assembly, but I don't want to start with this. I want to start with the core because this is the, so I'm going to properties here. Component properties. And I'm choosing the core. Now, by default, the first part is fixed. You see this little F here, it means that this is fixed. Now I'm going to use the control and the left click and drag, so I have it again. Pressing on it, going for properties, half rim. Doing it again, control, left click, dragging, I have the same. Because these are the same part. This and this and this are concentric. Okay, so you see chosen by default one of them and align the two others. Now I'm going to choose this one, for example, and see, I changed the alignment. Okay, and now I want this to touch this. Okay, and let's drag them aside. And I think we like this to meet this. Okay, and we like this one and this one and this one to be aligned. And this is it. And this is the assembly. And although three parts are actually the same parts from different configuration. Okay, thank you.